Assalamualaikum and good morning. So my name is AISYAH and now I am going to introduce Aspergillus species. So what is Aspergillus species? Aspergillus species are widely distributed around the world and can be found in various substrates. Their spores are airborne, allowing them to spread easily through the air and colonize organic materials such as soil and food products. Now you may be wondering, what does the Aspergillus do? How does it surface? So, these fungi play an important role in ecosystems because they help decompose organic matter and recycle nutrients back into the environment. In addition, Aspergillus is economically significant as some species are used in the production of enzymes, organic acids, and fermented foods. However, it is important to note that certain species can also cause disease in humans, animals, and plants. So Aspergillus belongs to the kingdom fungi because it is a eukaryotic organism. It does not contain chlorophyll, it obtains nutrients to absorption, and it reproduces mainly by spores. So in biological classification, organisms are named using binomial nomenclature. For example, Aspergillus niger is a species of Aspergillus, where Aspergillus represents the genus name and Niger represents the species name.
Hi, I am Hanis and now I will present the morphological characteristic of Aspergillus niger. Aspergillus niger belongs to the kingdom fungi, phylum Ascomycota, and it is a filamentous mold. On culture media such as PDA or SDA, it shows rapid growth. The colony are black to dark brown with a powdery or granular texture, while the riverside appears pale yellow to colorless. For microscopically, it has septate and hyaline hyphae. The conidiophore is long and smooth, arising from a food cell. At the tip is a large spherical vesicle covered by biseriate phyalides. The conidia are black, rough walled, spherical, and form radiating chains giving a black conidial head. This slide explains the nutritional characteristics of this organism. It is heterotrophic and mainly saprophytic, meaning it obtains nutrients from dead organic matters. In some cases, it can also act as an opportunistic pathogen. The organism uses absorptive nutrition by secreting extracellular enzymes such as amylase, protease, and cellulase. This enzyme break down complex substances which are then absorbed through the hyphae. For growth, it requires carbon source like glucose and starch, nitrogen source such as nitrates, essential minerals, and small amount of vitamins.
Hi, I'm Yana. We'll be continuing with characteristic of Aspergillus niger habitat. In general, Aspergillus is famously described as ubiquitous because its spores are found in almost all environments. But as for Aspergillus niger, it is specifically known as the black mold, which is a highly versatile filamentous fungus. Aspergillus niger is primarily a saprophyte, meaning it lives on dead and decaying organic matter. Critical role in the carbon cycle by breaking down complex polymers like starch, cellulose, and pectin. Talking about habitat, Aspergillus niger can be found globally in soil, litter, and compost. We also can find it in agricultural substrates as it is a major cause of post-harvest decay. The black mold rots in fruits and vegetables. Next, because Aspergillus niger is xerophilic, which can grow with low water activity, it frequently colonizes damp building materials, HVAC system, and household surface like the bathroom tiles. Not to mention, Aspergillus niger is also a thermotolerant, capable of growing in temperature ranging from 6 to 47 Celsius and can withstand a wide pH range from 1.5 to 9.8. Lastly, while most of Aspergillus is free-living, some species act as opportunistic pathogen in humans and animals, causing aspergillosis, or as endophytes in plants. Moving on to Aspergillus niger's reproductive system. While some Aspergillus species has well-documented sexual stage, Aspergillus niger is primarily characterized by its prolific asexual reproduction. Like shown in the slide, this is the main driver of its rapid spread. The first one is conidopore structure. It develops specialized hyphae called conidopores that end in a large globose vesicle. The second one is biseriate arrangement. In Aspergillus niger, the vesicle is usually covered by two layers of cells. The first layer, methylae, and the second layer, phyalides. The third one is spore production. The phyalides produce chains of globose, black, rough-walled conidia. These spores are hydrophobic and airborne, allowing them to travel long distance. As for the vegetative and survival structures, we have fragmentation and sclerotia. Any part of the mycelium can break off and form a new colony if conditions are favorable. And under extreme stress, Aspergillus niger can form sclerotia, a hard, compact mass of mycelia that stores nutrients and allows the fungus to remain dormant for years until the environment improves.
I will explain the significance of Aspergillus from biological, ecological, and medical perspective. Aspergillus is a genus of filamentous fungi that is highly significant in medical, biological, and ecological contexts. From a medical perspective, Aspergillus is important because it produces several valuable bioactive compounds. Some species, such as Aspergillus terreus, are used to produce antibiotic and statin like lovastatin, which help in cholesterol management. It is also produce immunosuppressant and anti-cancer metabolite, including compounds such as fumagillin and various alkaloids. However, Aspergillus is also associated with human disease. It can cause automycosis, commonly known as swimmer ear. It is a fungal infection of the ear canal, causing pain, itching, and hearing loss. In the lung, it may form fungal mass called aspergilloma or fungus ball. To the individual with weak immune system, it can lead to invasive aspergillosis, which is a serious and potentially life-threatening condition. Additionally, exposure to Aspergillus spore can trigger allergic reaction, including asthma type 1, hypersensitivity, and hypersensitivity pneumonitis, also known as Marfilza lung. In the term biological and ecological importance, Aspergillus play a crucial role in nutrient cycling, especially in decompositions of organic matter. It breaks down dead plant and animals into simpler substance, releasing nutrient back into the soil. This process is very important for maintaining soil fertility and supporting plant growth. In addition, Aspergillus is able to decompose complex materials such as cellulose, lignin, and even keratin. Because of this ability, it contributes significantly to carbon and nitrogen cycle, helping to maintain nutrients balance in the ecosystem. Its spores are lightweight and easily spread through the air, allowing Aspergillus to colonize a new environment quickly. Some species also live inside plants as endophyte, where they do not cause harm and may even help plant resist stress such as drought or disease. Although many species are beneficial, some Aspergillus species can act as opportunistic pathogen in plant and animal and humans. This show that Aspergillus can have both positive and negative impact depending on the situation. I will explain the significance of Aspergillus from biological, ecological, and medical perspective. Aspergillus is a genus of filamentous fungi that is highly significant in medical, biological, and ecological contexts. From a medical perspective, Aspergillus is important because it produces several valuable bioactive compounds. Some species, such as Aspergillus terreus, are used to produce antibiotic and statin like lovastatin, which help in cholesterol management. It is also produce immunosuppressant and anti-cancer metabolite, including compounds such as fumagillin. Beyond its medical and ecological importance, Aspergillus has wide-range industrial application. Many species are used to produce enzymes, organic acids, and secondary metabolites on an industrial scale. In the food industry, Aspergillus is essential for fermentation process used in products such as soy sauce, sake, and miso. In the pharmaceutical industry, Aspergillus species are involved in productions of antibiotic, including penicillin derivative, as well as statin and immunosuppressant drug. In biotechnology, enzymes such as amylase, protease, and cellulase produced by Aspergillus are widely used in detergent, textile processing, and biofuel production. Finally, in agriculture, Aspergillus species are used as biocontrol agent to manage plant pathogens and as soil enhancer to improve soil health and productivity. So overall, Aspergillus is highly versatile fungus and with significant benefits across multiple industries. Beyond its medical and ecological importance, Aspergillus has wide-range industrial application. Many species are used to produce enzymes, organic acids, and secondary metabolites on an industrial scale. In the food industry, Aspergillus is essential for fermentation.
Hi, I'm Marfilza Hanis with YUSMADI. This is an example product of Aspergillus niger, which is called citric acid. about 19% of the world's citric acid is produced using a microorganism called Aspergillus niger, which is common type of mold. Before the year 1917, citric acid was mainly extracted by squeezing thousands of lemons. However, Aspergillus niger can produce citric acid much more cheaply in very large industrial quantity by using simple sugar as a raw material. In the food industry, citric acid is known by the durable food code E330. Citric acid is a weak organic acid and it serves three main commission purposes. First, it acts as acetylene. It means it provides a sharp sour taste in products such as soft drink, gummies, and citrus flavored snacks. Second, citric acid functions as preservative by lowering the pH food. It creates an environment where harmful bacteria cannot survive. Third, it acts as a chelating agent. This means it binds to trace metal, preventing them from reacting and causing food to change color or spoil. Lastly, citric acid is classified as drugs, which stands for generally recognized as safe. This means it does not produce toxins that are harmful to humans during the production process. So this is the process from the microbes. The production of citric acids by Aspergillus niger is a highly efficient metabolic process that converts sugar like glucose or sucrose into citrate through a specialized series of biochemical reactions. First, we have the biochemical pathway. Second, overproduction. Third, industrial production. First, we look at biochemical pathway. In step 1, glucose uptake and glycolysis. Aspergillus take in glucose from the mediums. Glucose is broken down via glycolysis into fructose 6-phosphate. The enzyme fructokinase converts it to fructose 1,6-biphosphate. This continues until pyruvic acid is formed. Step 2, pyruvic acid enters the mitochondria. Pyruvic is converted into acetyl-CoA, releasing carbon dioxide in the process. Step 3, some pyruvate is also converted into oxaloacetic acid by the enzyme pyruvate carboxylase. This step is very important because oxaloacetate is needed to form citric acid. In step 4, acetyl-CoA plus oxaloacetate produce citric acid. This reaction is catalyzed by citrate synthase. Citric acid is the first product of the TCA Krebs cycle. In step 5, under the citric acid producing condition in lower iron, nitrogen, and phosphorus, enzymes like aconitase and isocitrate dehydrogenase are inhibited. This prevents citric acid from being further metabolized into cis-aconitic acid and isocitrate acid. In step 6, which is last step, citric acid accumulation and secretion, which is as the citric acid build up in the mitochondria, it is transported to the cytoplasm and then spread out of the cell into the fermentation medium. In step 2 is overproduction. In a healthy balanced cell, citric acid will continue through the Krebs cycle to be broken down for energy to make Aspergillus niger produce mass quantity of citric acid as a commercial product. The cycle must be broken or slowed down. First, high sugar concentration, typically 40 to 22%, suppress the enzyme catalytic dehydrogenase, which prevents the citric acid from moving further into the energy cycles. 2. Industrial producers strictly limit manganese and iron. A lack of manganese inhibits the enzyme isocitrate dehydrogenase, causing the metabolic pathway to stall and overflow with citrate. Third, the fermentation is kept at a very low pH below 2.0. This suppresses the production of competing acid like oxalic or gluconic acid, ensuring almost all sugar convert into pure citric acid. In third, industrial production, we have 4 steps, which is inoculation, fermentation, dispersion, and purification. First, we look at inoculation, which is the start. We add more spores to a sugary liquid like molasses. This gives the mold the fuel it needs to start working. Second, fermentation, which is the growth. The mold grows in huge air-filled tanks for about a week. This is where it eats the sugar and turns it into liquid acid. Third, the recovery, which is the suppression. We strain out the mold and add lime to the liquid. This makes the citric acid turn into solid white chunks so we can easily grab it. And 4, purification, the final product. We treat those chunks with a strong acid to clean them, then dry them out into the fine white powder you see in food. In summary, Aspergillus acts as a powerful biological tool that significantly shapes our world. offering both massive industrial benefit and complex ecological challenge. Industrially, it has revolutionized biotechnology by serving as a highly efficient microbial factory that produces the vast majority of the world's citric acid and essential commercial enzymes. Environmentally, while it plays a vital role in recycling nutrients by breaking down organic waste, it can also threaten food security by spoiling crops and releasing harmful toxins. For humans, the fungus is a paradox. It is safely used to manufacture ingredients in our daily food and medicine. Yet it remains a serious health risk as it causes respiratory infection in vulnerable patients. Ultimately,